Hello, welcome to today's biomechanics screencast. So the focus is on Newton's laws of motion. As you'll see from the specification, you are required to define and apply Newton's three laws of motion. So what you'll pick up from the specification as well here is that each law has a number and it also has a corresponding name. You need to know both of those just so you don't get caught out in exam questions. So first one, as we're looking at Newton's first law, or Newton 1, is known as inertia. Newton's second law, or Newton 2, is known as acceleration. And then finally we've got Newton's third law, or Newton 3, which is reaction. So before we go into actually defining and applying these laws, let's have a look at a couple of terms that are going to come up in all of these laws that we need to just be familiar with. So if we start off, first up, what terminology we need to know, then we'll start off with a body. You're going to hear this word body. Now, most people, when you do an A-level PE and you hear the word body, you're thinking about the human body, which is fine. But when we're talking about it from a biomechanical point of view, we need to make sure we can understand that when the body is used, it can be referring to an object, e.g. a ball, as well as the human body. So that's something to just be aware of. Next thing, we have to understand this idea of a force. So a force is known as a push or pull that alters a body's state of motion. Okay, so if we consider the body then, as I said before, let's think of it as a football. Okay, a push will be from the foot, let's say, kicking the ball, and that will alter the football, the body's state of motion. So it will move from where it was. So that's kind of what we'll be looking at. Now, this isn't going to be relevant for today's lesson as such, but it will be in future lessons. And if we're trying to work out a force, we need to know that it's equal to the mass times acceleration. Okay, so we need to know something, the mass of the ball times how quickly it's moving. Okay, and then in order to put that into units, which we won't be looking at for a while, it is measured in newtons. So that's just useful to have in terms of what a force is, what a body is. The equation there is quite useful. We might use it in when we're talking about one of the laws. So if you could just have that in there, and I will now take you through each of those laws in isolation. So if we start off then, we've got Newton's first law, which is inertia. Now, inertia basically refers to something being reluctant to change. Okay, so if we look at this from a sporting point of view, or in terms of the definition of the law, a body will want to remain at rest, it doesn't want to change, or uniform velocity, if it's moving, it wants to stay at the same speed until an external or unbalanced force is applied. So that's what we have to know. Inertia is the reluctance to change. Okay, in this case, we have to look at it from two key applications. So application 1, we need to have an understanding of this when we talk about it from a body remains at rest. So let's just start with this first bit here. A body will remain at rest until an external force or an unbalanced force is applied. So if we have a look at the action of a football kick, let's have a look at how this will look. So if we start off then first up, so we've got our situation here. So a body will remain at rest until external force is applied. So the football here will remain at rest until the external force of the foot to the ball is applied. So hopefully we can see that in action. So I'll repeat that once more. So the body or a ball will remain at rest until an external force is applied by the foot to the ball. And when that happens, the ball will obviously move. So you look at that and say that's pretty straightforward. The football will remain on the floor, rest, until the foot, external unbalanced force, kicks it. Okay, so let's have a look at this from the second application. So if we have a look into application 2 then, so what we're looking at now is the idea of a body remaining at uniform velocity until an external force is applied. So what does this mean? It means that once the ball is travelling in a straight line going forward, once it's going that way, it's basically saying that it will carry on at that speed, constant or uniform velocity, until an external force is applied. So if we have a look at that in action, so what we had before, so if we just imagine our ball had gone from here to here, it will continue at this velocity. It wants to continue at this velocity until external forces are applied. So what we have to know about here is how forces such as air resistance, okay, might act upon that ball. So if the ball's going that way, air resistance will act in the opposite way and then slow it down. Or we might have a situation where, in this case, it could be weight or gravity that is pulling the ball down. So it will stop it from moving at its constant or uniform velocity. So these are how these two external forces apply. You don't have to mention these necessarily yet, but if you do feel confident, if the ball's in the air, two things can stop it from traveling at its set velocity. One, coming down here, we've got gravity or weight pulling it down. Okay, the force of gravity or weight, or we've got the force of air resistance that opposes the motion of the ball through the air. Okay, so that's one way of looking at that. So how do we put that into action? Okay, so we need to say then, so a football will remain at uniform velocity in the air until the force of gravity or air resistance, which is an external or unbalanced force, causes it to slow down. Now, what I've just said into here, what you're looking to make sure you do is you've got this and applied it to the sporting example. So hopefully that is pretty straightforward. Okay, so that's our first focus on that. And I suppose when we're looking at Newton's first law, there are two applications for a reason. So what I'm going to do is just put onto an exam question for you so you can have a look at this and why I've taught it like that. So what you've got here, as you can see, define Newton's first law of motion. Okay, so it just says first law, it doesn't say inertia, so you need to say inertia and then build it up. From there, it then asks to explain why Newton's first law applies to a golf ball in the following situations. A golf ball on the tee, one. A golf ball in flight at maximum velocity. So that then shows you why you have to be able to apply these two parts or these two applications of the law of inertia. Okay, so that is what you're looking to do, and hopefully you can see how that works in terms of your ability to be able to apply the knowledge of that definition of Newton's first law of motion. So Newton's second law then is known as the law of acceleration. So let's have a look at the definition of this law. So in terms of definition, what we're looking at here then is acceleration of a body is directly proportional to two things. Well, one thing really, the size of the force. And when the size of the force is applied, it acts in the direction in which that force is applied. So that's what we're looking at. So acceleration of a body is directly proportional to the size of the force and acts in the direction in which it's applied. So our key application when we're trying to get this into our head and apply it to a concrete sporting example is how we apply the size of the force. Size of the force, okay, will dictate how fast a body accelerates. That makes sense, I'm sure, for a lot of people. I'm sure they can visualize that in their head now. But size of the force is not applied. We now need to apply it. So let's see how we do that. So size of force then, let's have a look how this would be applied. So we look at this now and think, right, so we look at this, we have got our two key, our same concrete example of a foot as the external force being applied to the body, which was the ball. Okay, so what this law, as we saw up here, the acceleration of this ball is directly proportional to the size of the force by the foot to the ball. Okay, so let's see how that one will work. So if you look at it now, the greater the application of this, we can't say size of the force, we've got to say the greater the size of the force applied by the foot to the ball, the faster the ball will accelerate. So hopefully you can see that in action. So we've got to be able to apply it. So in this case, the greater the force applied by the foot to the ball, the faster the ball will then accelerate. So hopefully that is a pretty straightforward way of applying it, and obviously it acts in the direction in which that force is applied as we went through there. Okay, so that is our second law of acceleration, and we'll do a little bit more work on that in lesson, applying it to different sporting examples. But for now, if we can just get the basic application linked to the foot kicking a football. So moving on to Newton's third law then. So this third law, or Newton 3, is known as reaction. Now what I have put in black there in brackets is action, reaction. The reason why I've put that is because it might just help you in terms of how you define the law. Okay, so if I put that into perspective, the law is called reaction, but for a reaction force to take place, an action force will need to precede it. What's the law stating then? It's saying that every action force has an equal and opposite reaction force. So let's put that into our same concrete example, looking at kicking a football. So what this is saying then, okay, is that the foot will place an action force to the ball. We know that. We've just looked at that with acceleration. But what's interesting and what we haven't mentioned yet is that whilst the foot is applying an action force to the ball, there is an equal and opposite reaction force from the ball to the foot. So if I put that onto here, if you have a look at what we talked about earlier when we were talking about this idea of forces being measured in newtons. So if you have a look into here and consider the following, we've got this idea that if you look at the red arrow here, that is to symbolise that the foot, in this case, is applying an action force of 200 newtons to the ball. Okay. At the same time, as soon as that happens, there is a reaction force in blue from the ball to the foot. Now, let me put this, sometimes it's going to be difficult to understand because the ball is stationary and you think, well, how can it apply an equal and opposite force? But if you think of a leg swing action, so if you think, imagine there was a football in front of you and you go to kick it and someone moves it away at the last second, and the speed and velocity of which your leg swing went through, and you'd end up with your leg follow through going maybe up to your head height, okay, because you absolutely go to whack it. Now if that ball is hit, if you place that action force against the ball and you look at the difference in your leg follow through, it will be nowhere near that because the equal and opposite force is being applied by the ball to the foot. So if I put that into action, for those who are struggling to see that, hopefully that makes sense. So how do we put this into an action? And it's really, really simple. So we just need to make sure we use our definition here. Anything in red we have to apply. So we have to say, where is the action force coming from? Where is the reaction force coming from? So let's have a look. An action force is applied by the foot to the ball, as we've seen there, and there is an equal and opposite reaction force applied by the ball to the foot, and that will slow down the leg swing as it goes through. Okay, so that's what we're looking at there. That is our key application for Newton's third law, action reaction. Please make sure you've made good notes with regard to both the definition, lots of gap fills in your corner notes please for that, and then on top of that making sure you've got lots of little kind of applications. If you want to think of some other applications to other sporting examples, feel free to do so. We will go through some of those in lesson. Thank you.